recording. Okay, screen one.
Tune is also recording, right?
Okay, so I was quite far in the other one, so it took me a while to redo it. So x of x r minus 1, x r plus 1. Coefficients are arithmetic. Arithmetic coefficients. And the thing is, you do this. That's the expansion that the arithmetic in. Okay. So yeah. So where was I on the other one? I was all the way. So this and r equals 0. And then it was n choose r. Yeah, n choose r. Okay, by the way, if you have questions, you can ask while I'm working it out. I'll answer them. Don't just sit silent. It's not gonna help you. And okay, just open my notes. And we do times x r. Now, does anyone know why I didn't include 1 in my equation over there?
Because it doesn't matter what power you use, it's always going to equal 1.
Exactly. Doesn't matter at all. So, because 1, unless it's -1, no matter what power I use, it's just going to be 1. I won't change the answer in the grand scheme of things. So, hold on. But I'm doing this afterwards. So if you want me to send this to you, you gotta tell me beforehand. N choose r minus 1 plus d is equal. D is a common difference, by the way, and this is a coefficient for x r minus 1. Okay. Hold on. All right then, so let's continue. And this, okay, this is all equal to n choose r. So since we know that so this is our n choose r minus 1 looks like n factorial over, looks like n factorial over r
Bro, which one
minus
is
1.
this?
It's 15.
Sick.
Yeah. So it's r minus 1 factorial. Then it's n minus r plus 1.
Plus 1.
Yeah, because this written now is technically looks like this. N minus r minus 1. And then you
and then you
distribute
just
that.
distribute. Okay.
Yeah. So yeah, that's that. That's n choose r minus 1. And then n choose r is just n factorial r factorial times n minus r factorial. No questions?
Why there are plus 1?
Like I said, this right here is equivalent
Oh,
to
okay.
this.
Okay, never mind, my bad.
Yeah. Any other questions?
Good so far.
Okay. I'm not really worried about you, Jake. I'm worried more about the other people in this call. And
Bro, you need to be worried about me more than anybody.
okay. Let's continue. So using this equation that we have over here, n factorial over r factorial n minus r minus n factorial r minus 1 factorial times n minus r plus 1 factorial is equal to d, right? Hold on, let me just make my canvas bigger. Okay. Everyone understand that? That makes sense? Okay, hopefully it does because it's not gonna get any easier. Okay, so now we have to make these. We have to figure out what D is, right? So before we do that, we have to find the common denominator. Now, if you can see, we have up here it's the same. But the common denominator. So to get here, oh sorry, to get here from here, what would you have to do?
R minus 1, so subtract 1.
Wait 1 sec, my dad's calling. Sorry about that. So where were we? Right. So what do we have to do to get r minus 1 factorial to equal to r factorial?
Add 1.
No, you wouldn't add 1. Does nobody know?
No, that's why we're here.
Okay, so r factorial is equal to r times r minus 1 times r minus 2 dot 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 all the way to 1, right? And guess what that is? That's r minus 1, right? Or even do you understand?
So do you add like R plus 1 or something?
No, because you
No,
know
since if it's r plus 1, that means r plus 1's included, but this one's just, it just goes down. So it's just r.
exactly. You just multiply this by r, then you get r factorial because r factorial is equivalent to r times नहीं कर सकते मम्मा हम busy हैं. So r minus 1 factorial. Those two are equivalent expressions. So that's why if you want to get r minus 1 factorial to r factorial, all we have to do is multiply it by r. That makes sense? I'm hoping that's a yes. So we multiply r by top and bottom, so it would be r times n factorial over this is this one over here, by the way. I'm rewriting it. R n factorial over r factorial I have a feeling that I'm doing this wrong, but let's go with it. So, okay, yeah. So do this, and now if you want to get this to equal this, what would you do?
N minus R plus 1.
Yeah, you multiply this side by n minus r plus 1. So this side just stays like that, n minus r plus 1, because this is bigger, so it just stays like that. And then this side we multiply by, so we rewrite it as n minus r plus 1 on the bottom. So it'd be r r factorial n minus r plus 1 times, no, over, under n factorial times n minus r plus 1. Right? Yeah. So you could write this out as n minus it would be n minus wait. The denominator is the same. So it would be r factorial minus r plus 1 factorial. R, and on top of this, it would be n minus r plus 1 times n factorial minus, yeah, okay, I got this. So minus r minus, r and factorial. Okay. And since this is our equation over here,
Wait. Explain how you got the numerators.
oh, the numerator. So for this one, this right here, like this one right here, is this, right? So for this one, all we did was we multiply r by this by r, right? Right?
Mm-hmm.
So you multiply the top and bottom are the same thing. So r times n factorial is r n factorial. And for the bottom, it just turns into r factorial n minus r plus 1 factorial. Now for this equation, we have to get this to equal this because this term over here is bigger. Okay? Do you
Mhm.
understand why it's bigger?
By the +1.
Yeah. So we multiply that by top and bottom of this equation over here. So multiplying by the top gets us this. Multiplying it by the bottom just makes it the same denominator. Right? And since the minus sign was here, since we now have the same denominator, we can subtract them. So this is the first numerator, this is the second numerator.
Okay.
Okay? Now, that's our first thing. Now, hold on, let me zoom out again and make this way bigger. Way bigger. Okay. So, all right then. So since that's our, so we'll write D is equal to n minus r plus.
Wait, he said like there won't be something as hard as this on the test, right?
Yeah, he said that.
Yeah. he
All right,
said that.
sick.
I'm pretty sure he said that.
Yeah, when we're doing,
He said that.
Listen,
it's-
I would fail the hell out of the test.
That's
if I
like
did
this.
anything
If you're
wrong
able
with
to understand
this.
this problem though, you should be set for the test.
yeah,
True. Yeah, I
Yeah.
mean, this problem is harder than anything you're gonna see, so.
Yeah.
So
Oh
this
my
this is
God,
only on the
Misha.
review. This is number 15 on the review. If you
Yeah,
don't know what
Michelle
I
I'm
mean,
here.
to be fair, there's different types of problems on the test.
Yeah.
Yeah.
But anyways, moving on. So D is equal to this.
Also, why did you call me here?
Why I call you here? Because I wasn't sure what I was doing for a hot minute, but like when you came here, I figured it out. So
Bro,
I
it's
mean, yeah,
just
me
his
and Partiv just
presence.
took a little bit longer than a minute to find out what the hell to do.
yeah, just yeah, a little bit. But
A little bit.
just stick with me here. If I do something wrong, just tell me because I'm probably gonna need that. So yeah, this is our equation. Now D is also equal to. No wait. Oh yeah, and N choose R plus 1 is. Wait, no, I got this wrong. N choose R minus N choose R plus 1 is also equal to D, right? Wait, no, it's the other way around.
Other way around, though, yeah.
Yeah. It's N plus R, I choose R plus 1 minus N choose R equal to D. Okay? So we'll write, again, we write that out, we get N factorial over,
Are you just repeating what you did before?
yeah, I'm repeating what you showed
Basically
us.
doing it.
I'm
like,
showing what you did
no.
in class. Yeah.
Or are you doing the second equation?
Yeah, I'm doing the second, I'm doing this.
Okay.
So it's N factorial R plus 1 factorial and then N minus R minus 1 factorial minus N R N minus R factorial is equal to D. Okay, now we just solve this out. So what we get is so in these two terms, which one is bigger? R factorial or R plus 1 factorial?
R plus 1.
Okay, so what would you do is you would multiply the top and bottom of this by R plus 1 factorial, so you'd get R plus 1. No, just by R plus 1, not R plus 1 factorial. So you got R plus 1 of n times n factorial over R plus 1 factorial. And then you get n minus R factorial. Now out of these two, which one is bigger?
N minus R.
Yeah. So then on this side, you multiply the top and bottom by n minus R by top and then n minus R by bottom. And you get you get n minus R close parentheses n factorial and then R plus 1 factorial, R plus 1 factorial and then times n minus R. That's how you get the common denominator.
Wait, would the factorial go on the numerator for N minus R too, or does it just
See,
disappear?
we're not multiplying by n minus R factorial, we're multiplying by n minus R. So
Okay.
that's why I wouldn't go there. So you understand why though, right?
Yeah.
Okay. So then this is equal to D, so we just solve this out. So it'll look something like n minus R n factorial minus r plus 1 n factorial over r plus 1 factorial times n minus r factorial. Now we have two values for d. This equation and this equation. That means they're both equal to each other, right? Right. So, you write that out. So it'd be equal to, what's the up here? What does it say? I'm gonna select this. Mm. Mm. Over here. And then I just erase that. Okay, and these two are equal to each other. These two are equal to each other. And what do we do here? You cross multiply. Right? Right. Right.
No way, this gets even more convoluted and backwards.
Oh,
Exactly what
it's
it
far
does.
more convoluted.
Exactly.
Like
Oh,
you haven't
yeah,
even you haven't
It
even
gets like
started.
really, really long.
You haven't even started yet. You just wrote
Oh.
down the two equations and simplified them a bit.
Yep.
Yeah, so now what
Don't
we do
even
is since
tell me
there's
that.
this
You know, you
n,
didn't have to do that at the beginning. You could have just cut off it because they were the same term, so it would have just become one at the very end.
huh?
Whatever, just continue.
Wait, explain that to me again. What'd you say?
Both of them, both of the equations for D have the exact same term, so you didn't have to simplify it like this. You could have just put them to one side and just put a 2 next to it.
They both equal to?
Both, there's, okay, whatever, just continue.
I mean, I'm just doing what
Basic.
MG showed us in during advisory, so I don't really know if there's a better way. But so
He
you
did this?
yeah.
Hey,
he
this is
did.
during
Yeah, I have
advisory.
the picture on my phone.
Yeah, I have it too.
Maybe I
Um,
should pay
$9 if
attention
you want me
more.
to send it.
Yeah,
no,
yeah,
not in
Trinae,
class.
maybe.
You did it during advisory.
Jake, can you
Wait, I'm
Okay.
in your class.
Maybe I should
Yeah,
come
Yeah,
to
I wasn't in
advisory.
class that day. Anyways, back to the thing. We can simplify n factorial off the top because it's everywhere. So then we get n minus r times, wait, no. You get n minus r minus r plus 1, which you can rewrite as n minus. I'm just gonna rewrite it. Yeah, I'm just write it out. N minus r.
just making sure this is recorded, right?
Yeah, this is recorded.
yeah.
It's gonna be
Yeah.
uploaded?
I'm gonna upload it probably right after this.
Okay, yeah, just tell me.
Also, I guess any naughty words.
Okay.
Jacob, wanna hop out of the breakout room?
No, Parker's staying here.
But I need to finish the rest of the thing.
After what? The
The
review?
review.
Yeah, we were just
Oh
finishing the
yeah,
rest
you
of the
do that.
review.
I'll just call you in here when you.
Okay,
Okay.
goodbye.
Goodbye. So over here we get. So I'm looking at what he does, and he does something like. Okay, r plus 1 factorial. And then n minus r factorial. Okay. N minus r plus 1 minus r. And then r factorial n minus r plus 1 factorial. So now what you can do is you can combine the top two terms. So that's n minus 2r plus 1. No, minus 1. N minus 2r minus 1 over, and this one is copying it. Choose this. And equals 2. And you can simplify this out and you would get n minus wait, what? Okay, I'm doing all right. So n minus 2r plus 1. You get that and that. Okay, okay. Anyone lost? Confused? Nope.
Nah, I'm hanging in just perfectly fine. You're right.
I'm being serious. Like,
Yeah,
if you
more
don't
than
understand,
you
just say it.
I mean, I joined in halfway, so I gave up.
I can go. I'll do that for you separately.
Do
after
that
I'm done.
later, bro.
Yeah.
Yeah,
Scrutiny.
exactly. I'm just doing another problem until you're done with this.
Okay, so after I got here, I'm supposed to try to get a common denominator. Yeah.
Shot. We have to do that now. It's
Yeah. So what you would do here is you'd multiply r plus 1 for on this side, r plus 1 on top and bottom. And on this side, you multiply n minus r plus 1 on top and bottom.
Do you have like the answers with you so I don't have to actually figure that out?
Yeah. So this would simplify, and this would simplify, and it'll be equal to. I mean, technically, if the same denominator, you can just like take them out and set this equal to n minus r plus 1. At this rate, we have the same denominator, so we can pretty much ignore them now, since they're the same denominator. I'm not even gonna write it out because we can ignore them. N minus 2r plus 1.
Wait, I don't get why you canceled n minus r plus 1 and r plus 1.
Wait, you don't this and that.
Yeah.
So
Yeah.
basically, what I'm doing here is when you multiply these two together and these two together, you get the same denominator on both sides. Okay?
Mm-hmm.
I don't know what that number is because I'm not going to do the math for it, but you get the same number, get the same denominator on both sides. It should look something like r plus 1 factorial. This is your denominator, by the way. Times n minus r plus 1 factorial. That's your denominator if you really want to see it.
Yeah, I got it.
And then after that, u as n minus 2r minus 1 is equal to n minus 2r, n minus 2r plus 1 times r plus 1. So you can multiply these. Is that what he did? Yeah. Okay. So you multiply these each on each side. So you get So on this, we're doing this side first, by the way. So it'd be n squared minus 2 rn minus n minus n no minus rn minus 3 wait, no, 2r positive 2r squared minus plus r okay, what do you do next? Plus r, okay, and then you do plus n minus 2r minus 1.
So how's that just simplifying both sides, right?
What?
It's like you're multiplying both sides, right?
Yeah, no, for this I'm
Or
just
is that, or is
oh,
that just the left term?
that was just the left side.
Holy hell.
So, and then you can just simplify that. So plus n minus n cancel out. Okay, then, and then minus 1. Okay, so it looks something like n squared minus 2r. Okay, minus 3rn. Right?
Yes.
Minus 3r and
It's 3r squared.
plus 2r squared
It's 2r minus 1.
minus r minus 1 is equal to, and you do this, you get r n minus 2r squared plus r plus n minus 2r plus 1. Now we're gonna set this up so that they're all on one side, so you just move them one by one. So what do we see? They'll automatically cancel out. Minus r, they have to be equal to each other on both sides. What do you do that cancels them out? I don't. So this minus 2r squared. Oh yeah, it is minus 2r squared. Yeah. Okay. I'm just gonna move this for my preference because that's what it should look something. Okay, so we put Rn Rn plus r minus 2r squared plus n plus 1 minus 2r. Okay, so we have that. This is not squared, this is plus 1. Okay, on the other side he put n squared minus Rn plus n minus n minus 2Rn plus 2r squared. Okay. Minus 2r. Oh, I forgot one term. That's why. It should be a minus 2r here. I forgot to put it from over there. Okay, now, yeah. Now it's looking good. So, now minus 2r, if you move all this to one side, right? So, minus 2r and minus 2r, if you move them to one side, they just cancel out because they become plus 2r. And they'll cancel out. So, we just remove them. So, these two can cancel out. If there's anything else that are the same term on both sides, they cancel out. Which doesn't look like anything. So now we just transfer everything to one side. So it'd be minus 1 minus n minus r plus 2r squared minus rn. Positive r. Yep, okay. Wait, no, this would cancel out too. With that positive r. I know it's kind of confusing because I messed up a little bit. If you have questions, I'll answer it right now. Cancel out. No questions. Great. So, yeah, so you do this. So then it'd be minus r and let me just rewrite this over here. N 0 equals n squared minus 3n plus 2r squared minus 1. And then we have minus rn minus rn minus rn. Then we have plus 2r squared, so plus 2r squared minus 1 and minus n just on the side. So it'd be n squared minus 4r and plus 4r squared minus 2 minus n. So this question is asking us to make it equal. Show us that. The question is asking us to show that n squared minus, oh wait, no, plus 4r squared minus 2 minus n times 4r plus 1 is equal to 0. That's what it's asking for. So we have n squared, we have 4r squared. We have minus 4n. Okay. Bum, 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 bum. Okay, so now we can rewrite this as n times 4r plus 1. Because that's equal to, and not plus, negative n. That's because that's equal to negative 4 Rn minus n. So so our answer, we got it from here, and this pretty much where you end your work. You can just write it out as n squared plus. So you can write this out as, I'm just gonna do something. You can write this out over here. Control C, Control V. This is equal to n, well, not equal to, but equivalent to this arrow thingy. N squared plus 4r squared minus 2 minus n 4r plus 1 equals 0. Does anyone not understand? Because I know that it's very confusing.
I understand.
I got it perfectly, for real.
Other than Trinae. Jake, do you get it?
I get it.
Harshita, do you get it?
Yeah.
So let me explain it now that I showed the works here. So, the coefficient of this, and this are arithmetic. So we know that, so we just make this is a general term, and then this is to find the coefficient. So we just we plug in r, in this case r minus 1, r and r plus 1. This is how we get and choose r minus 1 and choose r, blah 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 blah. So we know that they're arithmetic. That means n choose r minus 1 plus d is equal to n choose r. Okay, so then we write that out as n factorial, which is just n choose r minus 1. This part is n choose r minus 1. This part is n choose r. Yeah, that's just n choose r. Wait, no, other way around. This part is n choose r. This part is n choose r minus 1, which is equal to d. So as we simplify this out, we get, for our answer, we get this. Yeah, when you subtract these two fractions, we get this. That's our answer. So then we could put d equals blah blah. That's our first value of d. So then we also know that since the arithmetic, n r plus 1 minus n choose r has to equal d as well. So we factor that out, and then we get, so then we get for our d value, we get this buddy right here, I think. Hold up, let me check. If that's r plus, no, we get this thing right here. Yeah, that's our d over here, and this is our d over here. Since they're both d, that means they have to be equal to each other. So we simplify. So to simplify, we first have to we'll just simplify this out. So n factorial in the numerator, if we cross multiply, then they're gonna cancel out. We just remove n factorial completely, as long as, because there's 2 of each in each numerator. And then, so then we get this over here. So once we get that, what we do is we try to set the same denominator, which gets you this over here, this mess. Because r plus 1 times r factorial gets the same denominator, which is this over here, which is the same denominator. And then since we got the same denominator, we just can leave it out now, and we can multiply the numerator. No, we set the numerators equal to each other. So what we do is we expand these over here. We expand these two. We just expand them. So you get once you expand, you get this over here, which was originally which would be and so this would be the expanded version of this over here. The expanded version of this is this right here. So then now we set them so now we have to make them equal to 0, both sides. Make them equal to 0. So first we simplify numbers that are the same. So minus 2r. If you move this on that side, it'd be just plus 2r, which will cancel out. And then we're left with minus rn plus 2r squared minus n minus 1. So we move that onto this side, which we get with this over here. Now after we get that, we have to turn this to be equivalent to this. Now if you notice, minus 4rn minus n is equivalent to minus n times 4r plus 1, which is how we get this over here. And then this is how we get from this to this, which is our answer we're trying to get. Now, do you understand now?
Yes, thank you.
What about you?
I
Rashika?
gotta go figure out the other ones now. I'll
Yeah.
see you in Kundas.
Okay, so now that you understand that, I'm gonna go to 14. So, yeah, 14 says, okay. So, right? So A is equal to X plus Y, and B is equal to X minus Y. And then it says, use the binomial theorem to write A squared and B squared, A cubed and B cubed in terms of X and Y. So A cubed is equivalent to X plus Y cubed. And B cubed is equivalent to X minus Y cubed. So it's cubed. So how many terms do we have in the expansion? Oh, yeah, this is part B, which I'm looking at the wrong part. Sorry. And part A is asking A squared minus B squared. In terms of X and Y. So this would be equal to X plus Y squared minus X minus Y squared. So we simplify this out, we get X squared plus XY plus Y squared minus X squared minus Y plus Y squared. Understand that?
Yeah, I already did this one.
Oh, okay. And did you do this one too? Anushi?
I think she had to go somewhere.
Okay, then she's not yet. So what have you not done then?
14B, 14, all of 14 besides A, and then 17, 20, and 25.
17 I remember doing. Okay, so let's go to 14.
Wait,
Well-
can we finish 14?
Yeah, so I'm doing 14b.
Okay.
So A cubed B cubed X plus minus Y cubed. Okay, so how many terms will we have if we have 3 up here?
3,
No.
4,
Yeah.
4.
So we'd get X cubed plus X cubed squared Y plus X Y squared plus Y cubed. Now in this one we get same thing but switching letters. And switching signs. The positive, negative, positive, negative. So we got negative, which is Y cubed. Now in part, so this is we're done over here for part B. This is where part B ends. Part C says show that A cubed minus B cubed is equal to A, hold up, A minus B A minus B A squared plus B plus B squared. So first we have to combine these two terms over here. So we get 2x cubed plus 2x 2y.
Wait, why are we adding them?
Well, not adding, so we're subtracting. My bad.
Still, why are we subtract? I thought.
Because this is a.
Okay, I got
Yeah.
it.
So it'd be I'm gonna write this out differently now. I'm just gonna do that. Minus parentheses. So it'd be negative x plus x squared y plus x y. Oh wait, minus x y minus plus y cubed. Here you combine like terms, you get 2x squared times 2y plus 2y cubed, right? Hold up. We just need this. So let's combine like terms. This cancel out. this cancel out. Wait, no, yeah. And then, okay, so we only have two terms left. So this is equal to. So a minus b is x plus y minus x minus y, which is just 2y. So it's equal to.
How did you
2
get minus x minus y?
equal to what? What did you say?
Oh, never mind. Got it.
Okay, yeah. So equal to, so a minus b is equal to 2y times a squared is x squared plus x y plus y squared and okay plus y squared plus okay plus b is just x minus y plus b squared, which is x squared minus x y xy plus y squared. So you'd get something like x squared plus x squared is 2x squared. Xy and xy cancel out. Then you get plus 2y squared um, plus x minus y, right?
Wait, how do you get 2x squared?
X
Oh, got it here.
squared, x squared,
2x
and
squared.
y squared, and then all we have
Mm.
left is x minus y, because these two cancel out. Okay, then we multiply this by 2y. 2y. Then we get. Do you multiply that? Wait, hold up.
I think you do.
I'm gonna 2y 4y. So over here it'd be 4x squared y plus 2y cubed is equal to that. And this is equal to 4x squared over 1 times y plus 4y cubed plus 4y cubed plus 4y cubed, and then 2y times 2. Okay, plus 2xy minus 2y cubed. One sec, x. Hold up, we did something wrong. We should get. We should get. This should be 6y, 6x. That means I messed up somewhere over here. There's probably another y somewhere. Oh, right. I forgot the coefficients. That's why. The coefficients in this are. Hold up. I'm gonna have to like redo a lot of this. It'll be 2. Oh shit. Okay. Let's make a new one. Don't say. Um. Sorry about that. So yeah, after 14, after this question, what is this? 14. See, I'm just gonna go. This is my last question. I'll tell Kunika and everyone. You can watch whatever she's doing.
Okay.
Okay, so a cubed is equal to x plus y cubed, which is equal to x cubed 1, 2, 1, 3. It's 1, 1, 2, 1. Okay, so it's 1, 3, 3, 1. So 1, 3. Okay, and then it'll be the okay, so it's x cubed plus y plus 3 minus. hmm. Okay, now that is equal to negative x to positive 3x to y plus 3, oh wait, no, minus 3xy dot minus plus y cubed, then plus y cubed plus 3x 3 cubed 3xy squared plus 3x squared minus y plus x cubed. So now, oh, this is cubed. So now this cancels out, and these cancel out. Then we get 6x squared y plus 2y cubed. Now, the other one that we were looking at, it was a minus b times a squared plus b plus b.
Wait, wouldn't it be 6x to the power 2 times 2x? Wait, I'm confused.
2x where?
Because we're multiplying, we're adding x, we're adding, never mind.
We're adding
Yeah.
3x squared
Yeah,
times y. Yeah, okay. That's fine, that's fine. So this is equivalent to a minus b is equal to x plus y minus x minus y, which is x plus y minus x plus y, which is just y, which is just 2y. So 2y times a squared is equal to x squared plus 2xy plus y squared, and then b squared is x squared minus 2xy plus y, yeah, plus y squared, and then b is just x minus y. So what we can automatically do is cancel these out, which is equal to x. So we can add these together. So we get 2x squared plus 2y squared plus x minus y. So then if we multiply this, we get, you don't know what you do. This goes over here, and then this goes over here. So what do we get over here? Yeah. Okay. So then over here we simplify that into, so we get 4x yeah 4 yeah, it's okay. So 4x squared plus 2y squared, no, plus 4y cubed plus x minus y. No, plus 2 x y squared. No, plus just 2xy. And minus 2y squared. I'm gonna check if I did that right in the calculator. So a squared is x squared plus x plus y. Okay, did that part right? Okay, and then x plus y. X plus y. Oh wait, no. Okay. So then times oh, it's not B, it's AB in the middle. Okay, so it's not B. We're looking for AB over here. So that is not our full equation. We're not done. This is not our full equation. So up to this part is correct. Up to this part. Okay, so is equal to super easy. So this is x plus y times x minus y, which is just x squared minus y squared. Yeah, x squared minus y squared, which is again just equal to okay, x squared minus y squared. So minus y squared makes that equal to just y squared. And then minus x squared, it makes that equal to just x squared. Yeah, okay. That makes sense. And then we get 2x x squared. Wait, no. It's just 3x squared. So we get 6x squared y. And then we get plus 2y cubed. Do you understand?
Yeah.
Okay then. Okay, so that's easy.
So are we done at this round?
Yeah, that's the end of C, and then for D
Okay.
it goes to the same thing as B and C, except there's no like end result. So for D we just solve for a to the power of 4 minus b to the power of 4. We just plug in again, which is just x minus plus plus y to the power of 4 minus.
What does it mean by like factorizing?
The I'm gonna check the answers to figure it out, but I think it means just figuring out what it means. So let's see. That's 11. 14 starts there. So 14D. Wait. Huh? So okay, so on the answer sheet it says that after it solves for what it is, it, uh, oh, okay, yeah, okay. Then it just does that. Yeah, for D and E, D seems pretty straight. I'm for E, I'm gonna ask MG, but D seems pretty straightforward. Look at the homework one more time. So okay, so let's go past that for now. Oh yeah, 17 you did with us at tutoring, remember? 17?
Yeah, I have it. In my notes.
Yeah, you didn't do the notes though, right? For 17?
No.
Right.
Wait, all for this one, all we do is switch R equals 5, right?
For what?
For 17.
17?
Wait,
Let me write it down, okay? It's actually pretty simple, straightforward. 3 plus x 4 minus 2x power of 8. So we're gonna use this as our main when you're plugging it in. How so for 3x for 3, how many times do you have to plug in how many what sorry. This 3 is equal to 3x to the power of 0. So to get to the power of 5, we have to find x to the power of 5. And for this one, our second term is just we also have to find x to the power
4.
of 4. Yes.
Oh, yeah, I remember. Okay.
And then hold on, let's check my notebook just to make sure. X to the power of 4. Right. And then we just yeah, okay. And then so we can write this in sigma form, which is 8. In this case, it would be a choose R. Oh, that's not pretty, is it?
We only use 5.
A choose R. Yeah, we would use 5, but I'm just writing out the basic formula. A choose
Okay.
R 4. A minus R minus 2 R x to the power of R. Do you understand why I put the x out? It's originally 2x to the power of r, but do you understand why I took it out? I mean,
You distribute it.
distribute it. What?
Never mind.
Basically what happens is if my equation was let's say it was x negative 2x squared, and I wanna make it easier for myself, so I'll pull this out. It'll be power of r, which this is equal to negative 2 power of r, and then x to the power of 2r.
Yeah, I got that.
Okay. So now we just plug in 4 and 5 for each of them. So since we're plugging in 5, remember we're looking for the coefficient, right?
Mm-hmm.
So in the coefficient thing, it would be like 8 factorial over 5 factorial, 3 factorial, right?
Mm-hmm.
We have to multiply this by 3 because there's the 3 in this over here.
Wait, what?
So this is the
Oh, yeah,
coefficient.
yeah.
Right. So that's the only thing that you have to really factor in and take account for. And for the second one, x to the 4, you can just plug in 4 for all of these and not have to worry about anything because there's no coefficient over here.
And then would you multiply an x?
So then you'd get two different terms.
Mm-hmm.
Okay, and then it says then you'd combine those terms, right? Because if let's say that when you do this, when you plug in 5 for r equals 5, right?
Mm-hmm.
We plug it in, so the coefficient is equal to 20x to the power of 5, right?
Mm-hmm.
Well, 60 in this case because of the 3. So let's just
Yeah.
say it's 60. So then when r equals 4, it'll be r equal to 4. The coefficient will be equal to, let's say, 10 x to the power of 5, right? So at this point we just combine like terms, because when we expand it out, it'll be like plus blah 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 minus blah blah blah. It'll be expanded out, right?
Mm-hmm.
So then if we expand it out, it'll the term that has x to the power of 5 in it, it'll be 70x, because you have to combine these two terms. You understand it?
Okay. Yeah.
So like if you let's give an example. So let's say we're writing out 2 minus 1 times 3 minus 3. Okay, that would be, well, let me just use x instead of 2 minus x, no, x minus 2 times x plus 3. That'd be x squared plus 3x minus 2x minus 6. So this is what it would be like, because we have two terms with the same coefficient. I mean, it's with the same thing, which is x power of 1, power of 1. So that's basically what we're trying to do here. We're trying to find the two possible ways you can get x to the power of 5.
Okay, so I found them, so then would I add them?
So whatever you get after you plug it in. So over in this equation, where is it?
Go down like 2 times.
Whatever you plug in over here, plug in 4 or 5.
Mhm.
For 5 you do this for the choose r thingy, but after you plug it in, you should get a certain answer. I haven't done it yet, but you get an answer and then you just write it down. You write so like r equals thing, you write down the coefficient, and then r equals 4, you write down coefficient, and then you add, and then you write coefficient equals, and then you can write the
Okay.
coefficient that you got. That's your answer.
For this one, do we have to plug in through the whole formula since we're only looking for the coefficient? Don't we only need
Yes, you have to, because the 4 over here will contribute towards the coefficient,
okay.
because 60 times 4 is 240. Same thing with the negative 2. It'll make it positive or negative. So I mean, and it'll double the value. So yeah, these matter in this situation. But if they were 1, it wouldn't matter, but they're both not 1, so it matters.
Okay. Great.
Yeah, that's 17, and then 20.
We did that in class, I think, or in yesterday on Friday.
I wasn't there, but 20 seems pretty simple. It's the same thing as what you did for 15 at the very end, kind of. Yeah, it's not that bad. For 25 though. 7 I think we did this.
Mm,
Wait, did you guys do this in class?
no. I think the first one be combination.
So what I'm gonna do most likely is tomorrow during school. Tomorrow's A day, right?
Yeah.
I'm probably gonna ask him for a pass during first, second, and probably fourth period. At least try to, so that you can help me through these. Maybe, I mean, depending on how long, I'm gonna ask him for a pass during first. What do you have first period?
Or I can do fourth period because I have study hall.
Yeah. I'm probably gonna ask for first and fourth period tomorrow. I'm gonna ask my teachers, but
So we'll do it tomorrow then.
for 25, I mean that's what I'm saying. If Kundanika's doing it, then you can go through her lesson.
Okay.
I'm gonna go check what she's doing, but I won't be able to do the rest. I'm gonna stop the recording.